So we're now going to bring this in pink. That is his favorite color. That is why he chose pink here. So I'm also going to choose the very same pink.
Yes.
Question. Can I multiply out here? Or can I just take it like that? Is it making any difference to you? What do you think? What do you think is the best option? Because remember,
Yeah,
if it's negative 20, I must multiply it. Whatever this is, even if it's squared here, this thing here should be squared as well.
Yeah.
So I'll leave it as 1 term. Does that make sense? Let me just explain what I was saying. If I have it like here, 1 plus 2x, right? And this whole thing, let's say supposedly it should come in here. Because this is now 1 term, so this can be like 4x squared. And whatever this whole bracket is going to be, I square it where now I have to know what is that bracket square. You understand? So multiplying this out will not do you any good. Because then you have to take that 2 terms and square it. You understand? But it's easy now because it's 1 term, so this can be squared and that stuff can be squared. Okay? So 2x outside 1 plus 2x. 2x outside 1 plus 2x. 2x outside 1 plus 2x. So far so good. But now you see that negative is the same negative that is here, is the same negative that is here. You follow? No? So that is why we use the same coefficient. Because that thing is like similar like this, it's just like now something else. It's not 1 minus 2x like this, but it's 1 minus some other stuff. So it's still the same, it will still generate the same pattern. Yeah? But now you just have got more expansion to carry out. This first part is fine. This part, you need to know how to expand that part inside there. Pascal. This, Pascal. Alright? So I can do, that one is going to be 1. Of course you don't need Pascal, I'm just saying Pascal. So 20 times 2 gives you 40x, 1 plus 2x. That takes care of that. Then plus, what is 180 times 2x?
2x.
180 times 2, I mean 4x. 180 times 4x squared?
720x.
720 x squared. That is a 2x if you raise it to the power of 2. You get it? And then we bring in that bracket 1 plus 2x and we square.
Yes.
Minus, I'm going to do the other one, right? 2x cubed becomes 960 times 8, which is 7,680 x cubed. Bracket 1 plus 2x raised to the power of 3.
Plus.
So far so good? Okay. Now, looks like there's a lot of, this first one we can do, we can multiply out, it's not a big deal. So I'm going to go on here, right? Give you space so you can write it down. So this part can be done.
Yes.
That just becomes 1 minus 40x. And 40x times 2 gives you minus 800 x squared. Here comes the problem. Here, you're going to have plus 720 x squared, but now this is going to be 1
You already substituted.
plus, say what?
I see what you mean.
Okay, you want me to use NC, no need for that. Remember, if you want it like this, 1 times 1, and if it's 2x plus 2x, you do what? 4x plus what?
4x.
Does that make sense? So, it's not that much for you to work with, right?
It's not that much.
And here, this one here,
Yes. This one is the 4 term.
from Pascal,
4 term.
it will be that.
Yeah, this is the 4.
You follow?
Yes.
So minus, so I'm going to bring in the pink, which is the favorite color, of 7,680 x cubed. But now remember, 1 cubed, right?
Yes. Just
Plus, now we are going to the second one.
3.
So that's going to be 3 times, how much is it?
3.
The coefficient is going to be 3 now,
3 times.
right? But what do you do to find the second term?
No need to write the 1 because 1, anything raised to 1 is just.
Okay, I see people are getting confused. Let's do the thing the way it's done, okay? 1 cubed,
Yeah.
right?
Yeah.
And then 2x to the 0.
0. Yeah.
You with me? Plus 1 squared,
So just
2x to the 1.
1. Yes.
But remember, we are going to bring in other coefficients there.
Yeah.
Okay.
It's
Then plus 1, then 2x to the power 2. To the power 2. Alright? That's it. Okay. But now we said there's other coefficients here that must come. But it's still needed for me to do the other coefficients after doing this. This is most obviously the same stuff that I'm doing. Right?
But just simplify it.
People. If I was using NCR, well, how would I write it?
Let's see.
Just to give you an example.
3 choose. 3 choose.
NCR will be what?
3 choose.
3.
Choose 0.
Okay. I'm listening.
Plus.
We are here, right? For those of you who don't know.
Plus.
1 cube,
Which is just
2x, 0. The same stuff here.
1. The same.
So what I'm saying is, we don't have the coefficients. This ones are not there. Right? But we wrote them there for 1, 3, 3, 1. So basically, this now calculates them.
Yeah.
So if I go for the next one, plus 3, C1 will give me the 3. But you can see that this is not that, which is going to be 1 squared and 2x to the power 1.
Yes.
Good.
Which is.
Right. So I don't want to do that because I already said let's look at Pascal.
So you just substitute it in.
So I'm going to put in
The coefficient.
my values there, right? My coefficient. I'm going to put it in pink.
Which is 1,
So this is going to be 1 times, right?
3.
Let me just move this plus. This is going to be 3 times.
3 times.
Let me move this plus. This is going to be 3 times.
1 missing.
1 is missing. That one becomes, because it's supposed to be how many terms? 1, 2, 3, 4 terms, right? Plus
2x.
in yellow,
2x.
plus
2x.
in yellow, it's going to be
2x.
1 times.
2x.
Okay, that's what it's missing.
Failed there.
Okay, so this stuff in yellow, I'm just going to, because I don't have space, right? I'm just going to do this so that you can see what it actually should be, and then I'm going to write the whole thing nicely. No?
Yes.
That means I'm going to multiply this, that, with that. Because I need to multiply this answer with everything I'm getting here. So it looks confusing, but this is just going to be what? Up to there. It's just 1. Are you with me so far? Okay. So from there to there, it's what? 6x. 6x squared. Okay. You've with me so far. From there to there is going to be that's 4.
7. So is it square?
This is square, so this becomes 4.
No, I mean the first one.
The first one,
6x squared. Is it squared or is it just 6x?
or the first one here.
Yeah, it's 6x.
This is 3 times whatever that is.
Yeah, which is just.
Oh no, you mean back here.
Yeah.
It's just supposed to be 6x.
Yeah.
Okay, now let's come back here. This is going to be
3 times
12x squared
4. Yes. 8
plus
8. Straightforward.
That makes sense?
Yes.
Okay.
It's a long question.
I am just going to substitute this one here again because I'm running out of space for you to know that I'm supposed to multiply that with that, with that, with that.
My first one is just
Right. So, where do I start? Running out of space. 1 minus 40x minus 800x squared. Now here we come. Plus 720x squared. Okay? Then 720 times 4 gives you. Don't worry, I'll wait. 3,600?
2,880.
Oh, 2,880. X what?
X cubed.
Okay.
Same.
And then we go again. Same story, but this time to the power of what?
4.
I wonder whether we are not doing too much comparing to.
This is a long way.
It's the long way, right? What the book does. Alright, now I'm coming this part under. Are you with me?
Minus.
So it's minus. Now remember, this is a negative term. Ne?
Yes.
This is a negative term.
Yes, minus.
It's a negative term. So negative times that is going to give me.
Negative there. Just negative 7,000.
Can I write it here? Negative 7680 x cubed. And negative times a positive. Negative. So what is that times that? Negative times that. 7680 times 6 is what? 46080. Then
It will all be
negative times that gives you x to the power 5, yes? I think I must make more space.
92.
What is it? Huh?
92,160.
92,160.
X.
Then the last one.
X.
It's going to be negative also.
Negative, so everything will change.
So what is 7680 times 8?
61,400.
61,400.
440.
It was possible.
Raised to the
X to the power
6.
6.
Makes sense.
Yeah. But we have items.
I
We
see.
are not done.
It's not done. You can see
1,
2,
2,
and then the cube,
then
cube,
1,
2,
2, are you with me?
4,
Then this one,
and then this one on top.
and this one on top. I think the other terms were unnecessary. But we'll see. So 8 for me, minus 800 plus 720.
What is it? Negative 1.
It's what? Negative what?
Negative 80.
Good. Negative 80.
X.
That's already 3 terms. I want one more. The cube ones.
So minus 4,000. How much?
Negative. Yeah. It's negative. Negative what? Negative 4,800.
Really?
Right. Let me ask you something. Why do you think we have x to the 4 and x to the 5, x to the 6? You know where our problem comes? Here. Was it necessary for us to
Do all.
multiply this all out?
No, just the first.
We remember what we are looking for. We are looking for the first 4 terms in ascending powers of x. So one will be x to the 0, the second one will be x to the power 1, the third one will be x to the power. You follow what I'm saying? The first term is x to the power 0, that's that term. X to the power, that's the second, third, fourth term. So we expect our fourth term to be x cubed. So when we are doing this, there is no need for us to do NCR where n is what? 3, right? We did not need to go 3C what? see 1.
3.
We only needed to end up to there. Which one is that? Only this one and this one. Not that. Do you follow? There was no need for us to multiply this. Because automatically, even in fact, let's just look nicely at this. Right? We're not even supposed to go this far.
Just the first one.
Just so you can see, I'm going to take this off and I'm going to write it in the notation, binomial exponent notation. So you can see what I mean. Right? So this becomes,
Just the first.
this becomes 3, 0. Yeah? Now I'm talking about this one. Right? Then it's 1 cubed and 2x to 0, right?
Yes.
Good. So this becomes actually a 1.
Yeah.
Okay, so I'm just going to write this as 1. This whole term will be 1.
Yes.
The second one will be 3, 1. Right?
Yes.
Where this is 1
Raised
power what?
to
This was now power. This is power 3, right?
Which is
Power 2. And the second thing is 2x raised to the power 1. We don't need to continue, people. Because if you multiply this cube with whatever you get here, first if you multiply with this, you're going to get a cube result.
It's already
But if you multiply with something here, you're going to get x to the power 4.
4. Which we don't need.
So we don't need that.
Just the
But
first one.
do you see that? That's why it seemingly look longer for us to do that. But I did that purposefully so that you can train, especially the way it is formulated, these things in your book. Looks complicated, but it's not. So there's a little bit of thinking involved, where the highest term will be x cubed. So that when you are doing the other binomial here, you don't have to do the whole thing, because you're going to get terms that are not necessary. You understand what I'm saying? Because you should only write the first 4 terms. Does that make sense? Does that make sense? Right. And when it's the first 4 term, that coefficient of the 4th term must be 1 less because it will be x. But I see that anyway. But I hope you see that for practice purposes, the relationship between something like this which feeds somehow in something like that. That's why I said let's do that. I knew that from the onset this is a very long thing. And I also knew that it will be tough for you when you are trying to do it there because you can easily make mistakes. So algebra, and I purposefully went so far. That's why I was saying Pascal here. And I was waiting to see if someone can bring in the reasoning. It wasn't coming.
You were there, sir.
Takes a while. So this is 3C0. Right? 3C0. Which is 1. You get it? Right? So I can help you, maybe because you are recording this. I'm going to write this as 3C0, where the first term is 1, you cube it, and then the other one becomes 2x to the what? To the 0. Plus dot. Then you don't need this. And this is where you will be ending.
Which is just the 1.
You follow? Right, so when you take that off, then you will never have these terms.
This
off.
one here from here.
This. You will not even be there. Okay? Can I show you that? No, you get that. Please. These things have what? The format.
The format. Standard procedure.
So the book makes you, that's why I decided, let me take, well, I said last night, I was like, looking at the book and I said, I don't really like to have the lesson the way the book is designed. Because it makes you do a lot of things. You understand? And you need to get to the stuff faster. But it's still very useful. Now, when you look at example 45, just before I continue with the other stuff, they are saying expand that binomial using binomial theorem. So this is just now the binomial theorem that I introduced to you, NCR. Now you just use NCR there. Yeah. Now you just have to identify what is your A, 3x, and your B will be that minus y over 2. Okay? So you can have a look. You see they wrote it in vector form. 4C0, 4C1, 4C2, and then the powers of the first one decrease. The powers of the second term increase. And then you only do, because they say all the way up to the power 4, so you need to have 5 terms at the end.
Yes.
Does that make sense?
Yes.
Good. But what is very important there, and I want you to remember that, is that please do not use decimals when you are dealing with questions like these. Alright? Because you have got something on top, something under. And sometimes you have to square the stuff on top and under. Don't work with decimals. Because you'll have too many things to write down. And maybe you end up with a decimal that recur. And then you have a problem. And then you start rounding and a rounded answer is not an exact answer. Okay? So work with fractions. Remember what I told you all along, all these years. Fractions are very accurate. Okay? And even sometimes we accept an answer when you give it as an improper fraction. Especially with these things. So that is what that try now 45 seeks to. So I'm going to go back to the general term. I spoke about it briefly this morning. So I'm going to give you how many questions? 3 questions. 2 questions here. The third one is it's a little bit tricky.
Which one?
I said page. Yeah.
Page.
We are now focusing on. Right. Let us just recap what we have been doing so far. We have been looking at a coefficient
Expansion.
of something. Do you know how to do the binomial expansion using NCR?
Yeah.
Pascal's triangle. You understand what I'm saying? When you are asked to find a coefficient of x to the power 6 in an expansion, then you just go for that NCR, whatever is on top, the binomial, whatever it's raised to, then C to that 6. Is that fine? And then obviously you play around with the indices there to find those values. And it becomes constant, and constants can be calculated. Alright? Then you also had questions where you were supposed to write down like this one, the first 3 terms or something. Alright? That's basically how far we play. So without this really, it would have been a little problem, okay? And you also know that NR vector, which is the same as NCR, is factorial n over n minus r factorial times that. This can also be written, sometimes you'll see that a lot, where people write it as n factorial over r factorial times n minus r factorial. Same thing. You understand what I'm saying? Same thing. Of course, if you want 5C2, you can use your calculator for that. Alright? But otherwise, the long way would be 5 factorial over 5 minus 2 factorial. You see, I like to keep that 5. That's, for me, it's easy to work like that. Because it's like what I know now supposed to is what was on the top. Like it's similar, like, you know, sum to infinity. Okay? And then obviously here comes the small one, or whatever is being subtracted with, right? Which is 2 factorial. Now, the whole thing becomes 5 factorial over 3 factorial and 2 factorial. Let me ask you a question. 3 factorial, 2 factorial. I just want to see if you are thinking that this is equal to that. Remember, you have to prove. We know that this is 3 times 2 times 1 times 2 times 1. Now, this is nothing but 3. Double 3 gives you 6. Double 6 gives you 12. So this answer will be 12. But this is not going to be the case because this is already 6 times 5 was already 30. Can you see that? Can you see that? So please don't do that. Are we together so far? Don't do that. Alright? It's only when you like 5 factorial, 5 factorial. Yeah, of course, then those ones will be the same value when you multiply them down. You understand? Then you can cancel out 0. But you can't do that. And when you have a 0 factorial becomes 1. Okay, so please don't ever do that. Huh? If you're unsure, use your calculator. But anyway, this becomes here 5 times 4 times 3 times 2 times 1. All over 3 times 2 times 1 times 2 times 1. Then the 3 times 2 times 1 cancel. Can you see that? 2 goes here once and 2 goes there 2 times. 5 times 2, the answer is 10. Does that make sense? This is normal. Right? Or 5, shift button on your calculator. And on most scientific calculators like yours, then the NCR button is on the division. Is it not so? Press that and then you enter. Now when you have other things to do, like say for example you have got something like 5C3, then 5C4. Now you have this already in your calculator. Then you just go back and you delete the 3 and replace it with the 4. You don't have to press the whole thing. Can you see that? And also, once you have this, with whatever is being multiplied, other constants, just multiply it. You follow? You don't have to like what you were doing. You can do that, of course, but if you don't want to have so many things and then later on you end up making a mistake with multiplication where you have to take out a negative term and stuff like that, or a negative number, no? Negative factor. Is that clear?
I love negative.
That's what we have been doing so far. You see that this is actually a sequence. So we are now focused on the general term. And I already also brought that up. But I just want to bring this in with an example. Then we do 1 or 2 questions and then we look at what the technical section says. Yes, okay. Are you feeling sleepy? It's not easy.
You're gonna see something.
So I'm talking about this one here.
Plus 1.
So N's are A to the N minus R, B to the R. Good. So if you were asked to find the 20th term, if you must find the 20th term, because this is nothing but
R is 19.
This is nothing but R plus 1 term. Okay? But if I ask you to find the 20th term,
R is 19.
then you say R plus 1 equals to 20, then R equals to 19, which is what you're going to give me.
This is 1 less.
You understand? So who is 1 less? You have seen when we were writing the binomial expansion. Does that make sense? Okay? Now, let's look at this question. Find the 20th term. Relatively straightforward for now.
Take the specimen member.
No, it's not. So this could be question 7 or something like that. No?
Must we do it?
Yeah. Find the 20th term in the expansion of the quantity 1 plus x all raised to the power 40. Now again, how many terms, can I ask this question? How many terms will this consist of?
How many times?
Yeah, if you were to,
41.
that is trivial, it's tedious,
It's 41. It's a lot.
not necessary. You understand? So that is where the binomial expansion comes in.
It's crazy.
Alright, so I give you 2 minutes.
To do it.
Yes.
Find the 20th term. Simple. Straightforward, nothing.
I know.
Nothing you fear.
I want the constant and everything.
The constant.
Now I want the answer. I'm gonna sit because I'm also, she wants to stand, I'm gonna sit. I don't take it all. Because I believe you must be the picture of it. You should be done. What is NCR? What is your NCR? 40, C19. Please, let's speak for it. Yeah. So 14, that's it. Just say 14. Pause a bit. 19. Okay? Vectors you don't say over, otherwise you will start thinking of fractions. Right? 40, 90. Vectors describe lots.
Gracias.
But this is not a vector, please. It is just written like vector, like it's just a notation. You understand what I'm saying?
Yes.
So please, when we come and do 2D or 3D vectors, don't think about, oh wait, that was also vectors. No, that's not what it is. It's just a notation. It's just the way it's written. But you see that why I prefer to use the C, the NCR. Okay? Because you can easily make a mistake.
Into.
It's a horrible long number. But just give me the number S4CN and 19. Then what is the x raised to the power of what? Yeah, that's all. I don't want that. So that is a horrible number, right? What is that number? Does it even come in here? Yeah, it's telephone because it's a very long number, right? 10 times 10 raised to the power of 11. I did that on purpose.
So can I set this up?
Yeah, you can set this up. The 20th term is going to be n 40 c x raised to the horrible number. Let's leave it like that. There's a reason why I'm giving you this, because I'm going to give you another question so you can see the fundamental differences between the two questions. Okay? So that could be your question 1 of this particular. So question 2 here then would be, are you okay? Okay. You must say if you need a break. Find the coefficient of x cubed in the expansion of the quantity x squared plus 1 upon 2x raised to the 9th power. The key question you must ask yourself is, what do you think the key question is? What is the difference between these two questions? Find the 20th term in the expansion of good. Find the coefficient of x cubed. Looking at our general formula, here we don't know. I'm looking for.
Let me try it. Let me try it out.
We don't know this. So we don't know our R here. Do you understand? So what do you do? This is where you come to the what do you do? What do you do?
What? Which position?
We can write this, I can write this as 9C, but that's R. Think from there what we x cube, x cube, x cube, x cube. So this one will be x squared 9 minus R